I'm M. Yogita from CSM. Here I'm going to explain about interrupts in digital logic and computer organization, and the subject code is 23 ECE307. First, what is an interrupt? The interrupt is a signal emitted by hardware or software when a processor or an event needs immediate attention. When we perform an action when immediate attention is needed, that interrupt signal is emitted. It alerts the processor to a high priority process requiring interruption of the current working process. In input output devices, one of the bus control lines is dedicated for this purpose, and it is called the input service routine ISR. One of the bus control lines is dedicated to input output devices to perform these actions, and high priority processor is also required. Interrupts play a key role in a CPU tasks and system performance. If you are preparing for gate or simply want to master operating systems, the gate CS self-paced course offers a solid foundation. When a device rises an interrupt at, let's say, process I, the processor first completes the execution of instruction I. When we perform an action I, the processor completes execution of instruction. It processes one instruction, then it loads the computer counter with the address of the first instruction of the ISR. Before loading the program counter with the address of the interrupted instruction is moved to a temporary location. When program counter with address is loading, before that the interrupted instruction is moved to a temporary location. We allotted at some temporary location to that the executed instruction. Therefore, after handling the interrupt, the processor can continue with process I plus 1. When the processor is handling the interrupts, it must inform the device that its request has been recognized so that it stops sending the interrupt request signal. Also saving the registers so that the interrupt process can be stored in the future increases the delay between the time an interrupt is received and the start of the execution of the ISR. This is called interrupt latency. Types of interrupts. There are two types of interrupts. One is software interrupt and another one is hardware interrupt. A sort of software interrupt. A sort of interrupt called a software interrupt is one that is produced by software and or a system has opposed to hardware. Which software interrupt means which opposes the hardware is called software interrupt, and one that is produced by software. Traps and exceptions are other names for software interrupts. There is another name for software interruption, that is traps and exceptions. They serve as a signal for the operating system or a system service to carry out a certain function or respond to an error conditions. Generally, software interrupts occurs as a result of specific instruction being used or exception in the operation. In our system, software interrupts often occur when system calls are made, in contrast to the fork system call, which also generates a software interrupt. Division by zero throws an exception that results in the software interrupt. A particular interaction known as interrupt instruction is used to create software interrupt. Interrupt instruction is used to create software interrupts. When an interrupt instruction is used, the processor stops what it's doing and switches over to a particular interrupt handler code. The interrupt handler routine completes the required work or handles any errors before handling back control to the interrupted application. Whereas hardware interrupts, in an hardware interrupt, all devices are connected to the interrupt request. In hardware interrupt, all devices are connected to one interrupt request line, a single request line used for the all end devices. Suppose we have end device, that all end device is connected to only single request. To request an interrupt, a device closes its associated switch. When a device requests an interrupt, the value of INR is the logical or of the requests from individual devices. Hardware interrupts are further divided into two types, that is maskable interrupt and spurious interrupt. Maskable interrupts means hardware interrupts can be selectively enabled and displayed thanks to an inbuilt interrupt mask resistor that is commonly found in processor. A bit in the mask register corresponds to each interrupt signal. On some systems, the interrupt is enabled when the bit is set and disabled when the bit clear, but on another systems, the interrupt is deactivated when the bit is set. Suspicious interrupt and a hardware interrupt for which there is no source is known as a spurious interrupt. This phenomenon might also be referred to as phantom or ghost interrupts. When a wild or interrupt circuit is connected to a level sensitive processor input, spurious interruptions are typically an issue when system performs badly. It could be challenging to locate these interruptions. The sequence of events involved in handling IRQ. Device rise an IRQ. The processor interrupts the program currently being executed. The device is informed that its request has been recognized and the device deactivates the request signal. The requested action is performed, an interrupt is enabled, and the interrupt program is resumed. Where flowchart for interrupt handling mechanism. First start stage, interrupt occurs. When interrupt occurs, it processes the whole context and identify the interrupt, execute interrupt handle and restore the context, resume normal execution, then end. Whereas step 1 is any time that an interrupt is raised, it may either an input output interrupt or a system interrupt. The current state comprising registers and the program counter, it is then stored in order to conserve the state of the process. The current interrupt and its handler is identified through the interrupt vector table in the processor. This control now shifts to the interrupt handler, which is a function located in the kernel space. Specific tasks are performed by interrupt service routine ISR, which are essential to manage interrupt. The status from the previous session is retrieved so as to build on the processor from that point. The control is then shifted back to the other process that was pending and the normal process continues. Whereas managing multiple device polling, vectored interrupts nexting. Whereas managing multiple devices, when more than one device rises an interrupt request signal, then additional information is needed to the device, which device to be considered first. Polling in polling, the first device encountered with the IRQ bit set is the device that is to be serviced first. Vectored inputs. In vectored inputs, a device requesting an interrupt identifies itself by sending a special code to the processor over the bus. This enables the processor to identify the device that generated the interrupt. The special code can be starting address of the ISR or where the ISR is located in the memory and is called the interrupt vector. Interrupt nesting. In this method, the input-output device is organized in a priority structure. Therefore, an interrupt request from a higher priority device is recognized, whereas request from a lower priority device is not. The processor accepts the interrupts only from devices processing having priority. What is interrupt latency? The amount of time between the generation of an interrupt and its handling is known as Interrupt latency. The number of created interrupts, the number of enabled interruptions, the number of interrupts that may be handled, and the time required to handle each interrupt all affect interrupt latency. Whereas how many number of interrupts are there, how many enabled interrupts are there, and number of interrupts, how many interrupts are handled, and what is the time required to handle each interrupt, all these affected by only interrupt latency. When the device generating the interrupt needs a specific length of time to generate the interrupt latency is required. For instance, if a printer is printing a paper, the computer needs to stop the printing program and wait for the document to finish printing. The interrupt latency is the amount of time the computer has to stop the program from operating. How CPU react with when interrupt occurs. Interrupt detection. The CPU continuously video displays unit interrupt lines or alerts from diverse resources, consisting of hardware, gadgets, or software programs commands. To hit upon interrupt request. Interrupt acknowledgement. Upon detecting an interrupt request, the CPU acknowledges the interrupt using sending an acknowledgement sign to the interrupting device or software program. Interrupt handling. The CPU identifies the form of interrupt primarily based on its supply together with a hardware interrupt from a device or a software interrupt from a training. It then seems the cop with the correspond interrupt handler habitually within the interrupt vector disk, where context saving. Before moving manipulate to the interrupt handler, ordinary the CPU saves the present day execution context inclusive of the program counter, processor state, and any applicable sign in contents onto the stack or in the devoted garage. Transfer control. The CPU transfers manipulation to the interrupt handler or ordinary with the aid of placing this system counter to the addresser of the handler habitual retrieved from the interrupt vector. Interrupt servicing. The interrupt handler habitual executes to carrier the interrupt. It plays responsibilities to the interrupt such as reading facts from a device, processing enter outputs operations, or copying with a software program requests. Whereas benefits of interrupts. Real-time responsive. Interrupts permit a system to reply promptly to outside events or signals, permitting real-time processing. Efficient resource usage. Interrupt-driven structures are more efficient than systems that depend on busy waiting or polling strategies. Instead of continuously checking for the instance of event, interrupts permit the processor to remain ideal until an event occurs, conserving processing energy and lowering energy intake. Multitasking and concurrency. Interrupts allows multitasking with aid of following a processor to address multiple tasks concurrently. By improved system throughput. By copying with the occasions asynchronously, interrupts allow a device to overlap computation with input-output operations or other responsibilities, maximizing system throughput and universal overall performance. Whereas conclusion, the events known as interrupts alert the CPU to handle the request. Both software and the hardware can create interrupts. Maskable and non-maskable interrupts are two categories of hardware interrupts. Generally speaking, exceptions and special instructions like fork or what trigger software interrupts after completing the service request and handling the interruptions. The CPU continues the process where it left off. Thank